Hi, welcome in our railway engineering lab, and in this video we will discuss the working principle of a pantograph. Over here we are standing next to our Stammen type pantograph, and I will start with the beginning. How does the pantograph actually lift up? Normally this is done via compressed air. The compressed air enters the pantograph into this lifting device. This lifting device generates a force which pushes the frame upwards. The pantograph itself is mounted on the roof of a train by means of these isolators, so that it is electrically isolated. The force generated by the lifting device are transmitted by the lower arm to the upper arms to the collector head. The stabilizing and control arms are strategically placed in order to impose the vertical translation of the pantograph.
On top of the pantograph structure is the collector head. As the name suggests, this is the part responsible for collecting energy. The collector head on this pantograph has two contact strips attached. But there are also pantographs with just one strip, especially in the case of light rail systems. Most often, carbon contact strips are being used. This material has superior characteristics, as it has a low electrical resistance, good thermal conductivity and does not melt when high temperatures do occur. The contact strips should be strong enough and not prone to fatigue, as the contact force between the pantograph and catenary is constantly changing. Besides, its weight must be as low as possible, as the collector head must be able to respond very quickly to the always changing height and elasticity of the catenary.
A well-functioning pantograph follows the catenary very smoothly. In order to achieve that, the pantograph has to withstand various frequencies. The frame, the lower frame, is responsible for low frequencies, so the movement is very slowly. If we look on the collector head, that is responsible for a lot more higher frequencies. You can see that on the springs over here, which are very flexible. In that way we try to achieve that the pantograph follows the catenary motion. Over here you see two winglets on this pantograph installed. Not every pantograph has such a winglet. This is in order that the dynamic behavior of the pantograph is the same traveling forwards with the knuckle forwards or with the knuckle backwards. Over here we are standing to a different type of pantograph, a Waveley type of pantograph. You can see that the pantograph is very much simpler actually. Over here we are standing next to our Waveley pantograph. It's a different type of pantograph, a different type of manufacturer, and you can see some clear differences between the previously mentioned Stammen pantograph and this Waveley pantograph. Already you can see that the collector head is very much smaller. And you can also see that the type of suspension of the collector head is very much different. Over here, this pantograph has been used in the past, and as you can see on the horns over here, the contact wire of the catenary has moved a long way. The horns are responsible that the contact wire is again moving up to the contact strips if the catenary wire moves too much. That the contact wire is again moving up to the contact strips if the catenary wire moves too much.